So for this Pencast, I chose to do problem number 6 from the chapter 5 homework. And problem number 6 says that a train is going up a 2.88 degree slope at 4.37 meters per second when the caboose comes unhooked and starts coasting without friction. So we have a train that's going up a slope of 2.88 degrees at 4.37 meters per second. And the first part of the problem wants to know how much time passes before the caboose comes to a momentary stop. So the first part of this problem is just finding the time for velocity to equal 0. And in order to do that, the first thing that I did was calculate the acceleration. And acceleration can be found from the equation. Acceleration is equal to gravity times the sine of theta. And with this equation, was able to plug in acceleration is equal to 9.8 meters per second squared times the sine of 2.88 degrees. And that gives an acceleration of something around 0.4924 meters per second squared. Now, once you have this acceleration, you can then plug it into an equation to find the time. So you're basically just trying to use the acceleration to see how long it'll take the train to come to a velocity of 0. So in order to do that, you take the time is equal to the velocity over the acceleration. So that gives time is equal to 4.37 meters per second over 0.4924 meters per second squared. That gives something like 8.9 seconds. So there's part A. You found how long it takes for the caboose to come to a momentary stop. Part B is asking how far did the caboose move on its own before coming to a momentary stop. And for that, we just plug it back into a equation from one of the previous chapters in order to find the distance. So that comes out to x equal x, the amount of distance it travels in the x direction, 4.37 meters per second times 8.9 seconds minus 1/2 over the acceleration, which is 0.4924 meters per second squared, times the time, 8.9 seconds squared. So you have to solve all this, and once you solve through, you get something like 19.4 meters. Although it asks you to express your answer using two significant figures, so just 19 meters.